Okay, so let's go first. Number 1 is new, and then go to number 2. Okay, from number 2 here, I can say that any name. So let's say foundation design. Foundation design. I can say that day 1. Okay, so then make sure that you know you put all this you know the files in one folder. So that's why I will click on the browse, and then as you like. So here I'm going to the desktop, and then create a new folder. So I can save it same name, foundation design. So here I say that Lincoln University College. Okay, so day 1, whatever you want to name it. Okay, so then I will double click on this folder to make sure that I'm in this folder, and then select folder. Okay, so right now we have this folder, and then for just saving, you know, all the STAAD.Pro generated files.
Okay.
Okay, are you with me?
Yes, yes, sir.
Okay, and then here you select the analytical. However, you can go to, you know, different modules, but right now we are not going to building or physical interface or modeler. So here we are going to have the analytical interface, and then select the unit as metric. Okay, and the last one is create the job. So as you could see here, you need to go through 6 processes. Okay. So now I will click on the create. Okay, so here I have the main interface of a STAAD.Pro Analytical Modeler. And from here, just for your general information, so it is the main workflow that we will strictly attach to this workflow. Okay, so we have the geometry, properties, material, specification, support, loading, analysis, and design. But right now, so we will go up to here.
Oh, okay.
Okay, analysis. Because for design, so for design, I will use this option, foundation design.
Okay.
Okay, so now let's start from geometry. From the geometry, the first option, so I will go to this option, grid. Okay, so if I open this grid system, so the first one is beam grid. Just go to beam grid. And right now, the command is active. You can see, you know, a small node.
Okay.
And each of this node right now by default is 1 meter. Okay, so this is 1 meter and this is 1 meter by default. Why? If you come to here, edit option.
Edit option.
Okay, see here, you can see the
oh, spacing.
The spacing. Okay, so by default is 1, 1. Okay. Let's close this. And now I'm going to have, you know, a 3 meter height story building. So that's why from here, as you can see, so I'm to put here 3 under 3. And then I can go to, for example, have 1 bay in X direction. Where is X direction? So here we have the global coordinate system. Okay, so in a STAAD.Pro we have like this. Okay, global coordinate system. Here is Y, here is X, and here is Z. So right now, in this direction, I have the X, and in this direction, I have Y axis. Okay, for this reason, so I'm just, going into the X direction to have the 5-meter bay. So that's why here, I will click here, and then, so come down, and then here, up to 5, and then press escape, just to come out from the command.
Okay.
So again, I can come to this option, see here, snap node to beam. Okay, I will select this option again to activate the command. See here, again is activated. So I will select from here, maybe this time I can go with 3 meters bay, or let's say 4 meters, okay, up to unit 9, and again, come down, press escape. So after that here, at the top, so you have this grid system, you have the checkbox. So we can check or uncheck for seeing or let's say for showing or hiding the grid system. So for this reason, from now on, I don't want to see the grid system. That's why I will uncheck this option. Okay, so right now I have this geometry. And right now I want to make a copy of this geometry. Okay, so I will select this frames. And then here under geometry, so under this tab, so here the first one, okay? If you go to the first one, you can see it is translational repeat. If I click on this, so here I have this option. So let's say, for example, in this course, I want to just create the 4 number of copies. Again, in which direction? This time in Z direction.
Okay.
Okay, in the Z direction. So that's why I will come here, number of steps. Step means copies, okay? So I say 4. Okay, and spacing in each step or in each copy. So I can say that 5 meter, I can accept it.
Okay.
Okay, and then here I have the option as link step. If I click on this, so what does it mean? It means that, for example, here I have one node, correct? Here I have one node, and here I have one node.
Okay.
So if I copy this one, let's say in another 5 meter, I have, let's say something like this, correct? And if I don't tick this option,
Okay.
if I don't tick this option, so just STAAD.Pro actually create another frame exactly like this. But what about this portion? So I don't have any, let's say, link between this frame and this frame. So that's why here we have the link step, which means this is the link between the previous frame or selected frame with the new one or copied one.
Okay.
Clear?
Okay.
Okay, but at the bottom, so I don't want to have any member because at the bottom I have the foundation, yeah? So that's why I don't need to have the link at the bottom. So here later on, I will have the foundation here. So I don't want to have any link or any beam from here to here. So that's why, so I will come here and say that open base, the second option. Second option means open base.
Oh, base.
Okay, so now just I set it, for 4 number of copies, and for each bay in the Z direction, I have 5 meter, and then link a step, open base, and then click here. Also important, so just change this one to Z. Okay, to Z direction, and then click OK. Okay, see right now I have in the Z direction. Okay, so right now in the Z direction I have 1, 2, 3, 4. Clear, Mohammed?
Clear.
Okay. You're doing with me, correct?
Yes, sir.
Yeah, please do it. And then from here, I want to maybe again select all of this and then make another copy in the Y direction, in this direction, to have, let's say, 3-story building, let's say. Okay, that's why, again, I will come to this option, again, under geometry,
Okay,
and
same.
here, under translational repeat,
Okay.
select this, and then change the direction to Y.
Y.
Yeah, and number of copies, I can say 2. And then here, the default setup spacing, so which means the height, I can say 3. So if you change 3, this will be automatically changed. Okay,
Okay.
these 2 5s. Okay, see here, just
Yes,
3,
sir.
3. And since here we are copying, in the Y direction or vertically, because here I have the columns, yeah? So here I have the columns. And these columns exactly act as link. Okay,
Oh,
that's why I don't need to select this link steps and open base in this direction. Okay, only in vertical direction, you don't need to do that. So then I will just come back here, Y direction, 2 copies. The height of each floor is 3 meters. No need to check link steps and then click OK. Okay, so right now I have this 3-story building. Okay, so
okay.
the next step, so right now, let's say I just, created my structure, the geometry of the structure. Okay, and then the next step, just to remind you, so we said that, here is the workflow. So then I can go to properties. So in the properties, I can assign the material and sections to beams and columns. Okay, so for this reason, here I have the option, let's say we can go for concrete structures. Okay, so here I have the define tab. Okay, click on the define tab. And from here, we have the different shapes for creating our concrete section. So for example, here I will select rectangle. And here you have 2 options, YD and ZD. YD is the depth of the, for example, if we are creating the beam, it is the depth of the beam. Okay, so it is the depth. And here it is the width of the beam or breadth of the beam. So for this reason, so first I'm going to define a section for the beams that I have. For this reason, I can say that the depth of the beam is 0. Let's say 45, and the breadth or width of the beam, I can say that go for 0.3. Why I'm saying 0.3? Please pay attention to the units.
Okay, meter.
Okay, so that's why here, which means we have the 450 mm by 300 mm. And then I can click on add. Okay, just add. Right now, you can see this member or section just created here. Okay, the next one, again, without closing this window, so I will go to define the column sections. So for column sections, maybe I can go for 45 by 45. Okay, 45 by 45. And again, so I will click on add. So right now here, I have 2 sections to just be used for beams and columns. And another thing here, you can see here, I have already the material. So it assigned as concrete. But if you open this drop-down menu, you have different materials. You have aluminum and also you have steel. Okay, for now, for this example, we are going to select the concrete. So that's why in this workflow that I showed you here, so usually we don't that much consider about the material, because already actually here we assign the material. So we can jump to other steps. Okay?
Okay.
So now I will erase everything and then close this tab. So I will come back to here, the first option. So here I have my beams section.
Okay.
And then, so if I go to select option, this option, select option.
Okay.
And then come to here, see here you have the cursor. So under cursor, for example, if you want to select the beams, so you can just select the beam cursor. If you want to select the node, you can select the node cursor. If you want to select the plate, if you have any plate, so you have the plate cursor as well as solid cursor. Okay, for example, if I select the node cursor, which means the first one, see if you select everything, just nodes will be selected, not members. If I change it to beam cursor, okay, and then, so if I select, see all the beams will be selected, but not nodes. Okay, and if I select the plate cursor, because right now I don't have any plate, so nothing will be selected because I don't have any plate. Okay, and then, so the next thing that you have, so here you have the, geometry selection. Remember, so we are under select tab. So whatever we are talking here about is about the selection. So you have the geometry selection. Again, here you have the node selection. So this node selection is a, in a faster way, and also beam, plate, and solids. So what does it mean? For example, right now, instead of selecting the beams, going to, for example, beam cursor, and maybe select the, the beams just like this, pressing control, and then selecting, this beams. So it is using the beam cursor. But here we said that, we have also other options to select the components or elements much faster. For example, I can come under beam, which means here, and then here I have the parallel option. Okay, so under this parallel option, if I open this, see here I have parallel to X and I have parallel to Y and Z. So right now, we know that here we have the X direction and here we have the Z or Z direction. So I want to select, all the members in this direction. Correct? So simply means beams. Correct? But I'm not going to select the, parallel to Y direction. Y direction, which means column. Here is Y.
Okay.
Correct, Mohammed?
Yes. Okay, sir.
Okay. So now I will go to the parallel. So I will select 2X. See here, all the X will be selected. Or again, so just let me, press here to unselect everything. Just to show you better. Again, come to here under beam and then parallel to X. See here, all the X, or let's say members in the X direction will be selected. Same, again, just go to parallel and this time go to Z. See right now, all the beams were selected. And do not forget that, so we were here, yeah? So in the first step, we need to select this because right now we are going to assign the section to these beams. So the steps is like that. So the first step, we have to select the section that we want to assign. And the second step is the selection. So we need to select the members. And then the third step here, I have assigned to selected beams. Okay, and then after selecting this, so the fourth and the last stage is assign.
Okay.
Here we have 4 procedures to assign a section to member or members. So for this reason, so I will go to right now, the first one I already did it. The second one also I did it. So I am going to the third steps. So which means assign to selected beams. So if, for example, it was just selected by other options, so I need to bring it back to assign to selected beams. Okay, so that's why this is important. And after that, so here I have the step number 4, which means assign. Assign. So here, just simply click yes. So here it says that the assignment method you have chosen is assigned to selected beams. The thing that we want. Do you want to proceed? Yes. Okay. So right now here you have R1. So R1, which means reference 1. Here, just next to this section, you have the number 1, number 2. And at the top of these numbers, so you have REF, which means reference. That's why here you can see reference 1 or R1. Okay, so the next step, I will just click somewhere here to deselect everything. And again, this time I will go to parallel, and then this time select to Y direction. See, all the columns will be selected. So please save your model, because sometimes actually, we have a crashing experience. Okay, so this time I will go back to here. Again, see here, I need to strictly attach to the procedure. See right now, I selected this columns, but once I change this one, everything again, just are deselected. So that's why the procedure is important. So again, in the procedure 1, I need to select the section. Then I need to go to selection mode, which means here I can go to Y, and then 3, assign to selected beams, yes, and then 4, assign. Assign, yes. Okay, so right now I have also R2. So right now we did it. If you go to View tab, here you can see the View tab exactly next to Select.
Yes.
Click on that, and then here you have the 3D rendering. So if you go here, you can see your structure. Okay, see here you have your structure. Okay, so now again, attaching to this geometry.
Okay.
So we did the geometry, we did the properties, we said material, we don't need to take care about it, because in the property also we assign the material. So under specification right now, I'm not going to say anything about the specifications, because specification, which means if you want to release any moment, or if you want to rotate for example, a member, so you can come to the specification. But right now also we can ignore this. So I don't want to go through this. And then, so the next step, so I want to go to the support. Okay, for this reason, just click on the support. So under here, in this window, you have the information. Let's say you have the option to define or create the support condition. So for this reason, so I will go to the Create tab, go to Create, and from here, we can go for fixed support, let's say, the first one, and then click Add. Okay, see here, I have the S2, support 2. So again, the procedure is same. So for assigning the support, so the first procedure is just, to select this.
Okay.
Okay, then you need to select the nodes. Okay, then here you need to assign to selected nodes, which means 3. And the last one, you have the assign option. So just I'm trying actually to make it easy as much as I can for you. Okay, so here you have this procedure, and then let's do it. So the first step is support. So the second step, so I need to select the nodes. For selecting the nodes, so right now maybe is not a good view to select, all the, base nodes. So that's why I will go back to view, okay? And maybe I can come to one of the elevation view, for example, left view or front view or right view, doesn't matter. So just I want to have the elevation view to select the nodes very easy. So that's why I will select one of these views, for example, here. Okay, and then from here, simply I can just select these nodes. Okay, after selecting this, so I will come back to isometric view from here just to make sure that all the nodes at the base are selected. So here I will select this.
Oh,
Okay, so right now, as you can see, so all the nodes were selected. So the third step is to select this, assign to selected nodes. It's selected already. And then the fourth one is just assign. Assign, yes. Okay, see right now I have the support.
okay.
Okay, so the next step, so here go to loading. I want to assign some load to this structure. So here, let's say I have, in reality, okay, let's say, for example, here I have the walls, yeah?
Okay.
Let's say here I have the walls, and even here at the first floor, and maybe here I have the walls, and also, let's say in this direction, I have the walls. Okay, for this reason, so right now I didn't put the wall, but I need to calculate the wall weight and then assign as a load to the beams, correct? So just as an example, so here I will go to, for example, apply the load to all these beams. Okay, the, let's say, uh, surrounding beams.
Okay.
So I'm going to assign the loads to these beams. For this reason, here, first I need to define the load type. So what type of load I have? I have the dead load, I have the live load, I have the wind load, I have the seismic load, I have the snow load. So what kind of load I want to assign to this? We said that we want to assign the wall weight as a load to these beams. So which means we are going to define the dead load type, correct? So that's why here I will select this load cases detail. And then from here, you can go to add. Okay, and from here, you have the load types. So I will select the dead. Okay, so before assigning the wall weight or load to my beam members, so also I need to assign the self weight for each element that I have, correct? And we know that self weight is again, is a dead load type. So that's why here I will say SW, so just to representative as self weight, and then click on add. Okay, so right now, as you can see here, I have this self weight here. Without closing this window, so I will add another load. So I can say that DL, which means dead load, add. Okay. And also I can go to change the load type, let's say as a live load. And then here I want to add the LL or live load. And then add, correct? So later, if you want to assign any other load types, so you can just, come and then change the load type according to whatever loading you have. So now just we are going actually now to assign the dead load and live load. Then close this window. So again, come back to here and then select the self-weight or SW. And from here, go to add option. So under here, so you don't need to do anything. So as you can see here, already the Y direction is selected and the factor is -1. Why is like that? Just to, let's say, assign the load in the negative Y direction as a gravity load with factor 1. So how the software is calculating this? Because we have the cross section, cross section for beam, cross section for columns, whatever actually we have the cross section for that element. And then simply, even by simple hand calculation, we can calculate the self-weight of each element. For example, here we said that we have the 300 by 450 mm beam section, correct? Okay. So then simply from here, you can say that if we want to go by meter, okay, so here we can say that 0.3 times 0.45 times the length. So for example, the length of this member, we can say that, is, let's say 5 meter. Yeah, so I can say times 5, and then times the, let's say the density of the concrete. Okay, for this reason, we can say that, times 25 or 24, okay? So here, because here actually we are talking about the reinforced concrete, so maybe we can say that 25. And then, so here it gives us actually, the weight of this beam. Okay. Okay, so in this way, but STAAD.Pro actually, not only STAAD.Pro, any other solution or any other software that we are working with, so they can automatically calculate this self-weights. Okay? Okay. So let me go back here. And then again, just to review, so I selected the self-weight, and then this window just appeared. Okay, so I don't change anything here, and then click add. Click add. So without closing this window, just go to dead load and then select dead load. Okay, so right now, from here, I have the member load. Remember, we said that we want to assign the member load, the load of the wall to the member. So that's why here I will select on the member load, and here I have the uniform force. So again, you need to calculate it actually, but right now just I'm going to put some arbitrary value. Here I can say that minus, because the direction of the load should be exactly in the negative Y direction as a gravity load. Okay, I put minus, let's say 3 kilonewton per meter for this member load or line load. And here I'm making sure that GY or global Y direction is selected. Okay. And then click add. So here right now, as you can see, I have this, let's say line load or member load under dead load. But let's say, for the, the inner beams, also I want to assign some load. Maybe I have the partition, something like that. Okay, so again here, I can change this one to -2. Okay. Okay, and then GY is selected, add. So right now I have 2 load types for member load under dead load. So again, without closing this window, so I will go to select live load. Yeah. Okay, so again, select live load. And then from here, again, I will go to the member load. And here I can say, for example, -5. So I want to assign to all beams. the primary beams and also the inner beams. Okay, and the GY is here, and then click add. And let's say, let's assume that we calculated our wind load, and then I want to assign this wind load to the structure. So which means I want to assign, let's say, for example, in X direction to all these nodes. Okay.
Okay.
So here, that's why I'm going to define one nodal load. You can see nodal load exactly at the top of the member load. So click on the nodal load, and then here again, it is in the X direction, yeah, in the X direction. So I'm going to assign the Fx, define Fx. So, and the force is positive because exactly it is in the X direction. So I can say that let's go for 4 kilonewton, for example. But all of this, just I'm using the some assumption. But in reality, we need to calculate these loads.
Okay.
Okay, and remember here, I'm just using as live load. Okay, if you want to create another, let me create another one. Close this tab. Don't do that anything. And then again, come to here, load cases.
Okay.
Select this, come to add, click on add. From here, come to wind. Okay, select the wind. And then here I can say wind underline X, which means wind in X direction. Okay, and then add. Okay, from here, I will select this load type, which means wind, and then add. Okay, I want to assign the wind as a nodal load. However, also in the STAAD.Pro, we have the automated wind load generation. Okay, but right now, again, I'm not going to discuss about that. Okay, right now I will select the nodal load, and we said that we want to assign in X direction. That's why here I will select Fx and put as 4 kilonewton.
Okay.
And then add. So right now here I have all these loads, and I need to assign to the structure, to the, let's say, appropriate or desired member. The first one is self-weight. I can select it. So self-weight should be assigned to any component because every component or any element has its own self-weight, correct? So that's why I will come to here, and then I say that assign to view. Again, let me just to show you the procedure, okay? Just again for easiness. So again, the first procedure from here is to select this, and again, you need to select the element or the nodes, whatever actually we want to assign. And then so here it is the third step. So select the appropriate option. And the last one again is assign. Simple, yeah? So now let's go to procedures. So the first one, I select the self-weight. The second one, I need to select the entire structure because we said that self-weight should be assigned to entire geometry.
Okay.
That's why here I have the assign to view. What does it mean? Which means whatever I can see in this view will take this load. Okay, that's why I will change the option to assign to view. Okay?
Okay.
And then, so the fourth step is assign. Assign, yes. So right now you can see, the entire structure is highlighted, which means this load is assigned already. And also, if you look at the, the symbol next to the self-weight, right? Previously, what, just like a, red question mark, but right now you have a green color symbol. You can see that? So means this self-weight is correctly assigned to the structure.
Oh,
Okay. For example, if you come under dead load and you have the actually, uniform gravity member load with value of -3 kilonewton per meter, you can see next to that load, you have the one red question mark. So which means it tells you that still you haven't assigned this load to any member.
okay.
But here we know that we want to assign this load to which members? To the beams, correct? To the primary beams. We said that we want to assign this load to surrounding beams,
Okay.
correct?
Okay.
So for this reason, I will go back to, again, select option, and then once again go to beam, and then here parallel to X, and also parallel to Z. So from here, I need to just, deselect the other beams, which means inner beams or secondary beams, which is inside this structure. So for this reason, I have a cool option. I can go to View tab.
Okay.
And then here I have the selected objects.
Okay.
So I want to filter the columns for now, okay? So click on selected objects. So right now, as you can see, only I have these beams. Okay, now I can come to top view. See here, I can come to top view, just like this. And from here, I can select the beams, just like this.
Oh, manually.
Okay, so just I select like this. And then for making sure that, all the surrounding beam are selected, I will go back to isometric view. Okay, see here, I have the isometric view. And now, again here, either I can go to assign to view, because here I have actually this, but here also I have, this, let's say, unselected members. If I select assign to view, which means this load will be assigned to all the, members that I can see in this view. So it is not the correct option. So that's why I can go to assign to selected beams. Okay, so change this one to selected beam. And again, the fourth and last step is assign. Assign, yes. Okay, see here, you have the loads. So we said that we created, this -2 kilonewton per meter for, let's say, interior beams. So again, I will select anywhere here. So again, look at the procedure. So the procedure 1 is select the load.
Okay.
Procedure 2 or step 2 is select the beams. So again, for this reason, I will go back to top view. And from here, I will select, let's say, this beam, this beam, this beam, and this beam. Okay, again, if I go back to isometric view, see here all the inner beams are selected. It is the step 2. Step 3, again, I need to change this parameter to assign to selected beams. Correct? And then from here, I can go to the last option. So here we have the assign, and then click on assign. Yes. Okay, so right now, we just did it. Okay, so the next one is live load. So we said that we want to assign the live load to entire beams. So from here, again, the procedure 1 is select the live load option, which means here -5 kilonewton per meter. Step 2 is select the members that you want to assign the load. Here, all the members or beam members. And then, so, or either from here, even, without selecting anything, I can use the assign to view, because here I cannot see the columns.
Okay.
That's why simply I can say assign to view. So in this view, what you can see only beams. So then you can assign, select assign to beam to view. Okay, and the last one is for. Okay, assign. Yes. See here, it assigned to all the beams. It is the live load. Okay,
Okay.
and if you go back to here, display whole structure under view. Go to here and see here, nothing is assigned to columns.
Okay.
So the next one is wind load. Here we said that we have the wind load, and there I can go to top view once again, because from here I want to assign the wind load as a nodal force to all these nodes that I have,
Okay, sir.
correct?
Okay.
So then from here, I will go to top view, and then I will select this, sorry, first you need to go to select, and then select the node cursor. Okay, and from here, you can select all these nodes from this side. And then for making sure the nodes are selected properly, go back to view and then come to the isometric view. See here, I have also this base node selected. So for this reason, I can press Control and then just once again click on these nodes to make them unselected.
Okay.
Okay, so right now I have this. So again, the procedure was like that. So the first one was selecting the wind load. The second, select the nodes. And the third, assign to selected nodes here, correct? And the fourth is assign, yes, yes. Okay, see here, you have this load.
Okay.
Okay, if you want to just, rescale the graphical view of this, loading, you can right click and then go to the labels. So here you have the scales. Okay, go to scales, and here you have the point force.
Okay.
Okay,
Point
so
force.
from here you can apply immediately. Click on this, and from here you can just play with this option. See here, you can just make them nicer. Okay, from here. Okay, so then click OK. So right now you have this, and right now we just assign all these loads to the structure. Save your model. The next step is to generate the load combination. Okay, again, for generating the load combination, I will come to select load cases details. Once again, come to add option. And then here, I want to go to define combination. So here we have actually two options. We have the define combinations manually, so I can do it. And this one is Autoload Combination. Okay, so here under Autoload Combination, so here you have the selected load combination according to the used code. Okay, for example, here, if I'm not mistaken, you're using Eurocode, correct?
Yes.
But here we don't have Eurocode for, let's say, generating the load combination automatically. That's why maybe it's better to come to define combination by yourself. Okay, but if you want to use this option, maybe also you can use, for example, British code, and then you can generate the loads, for example, just like this. Here you have the generated load, and then you can add it. Later on, you can edit it based on the Eurocode. Okay, but for now, just I'm again to show you how we can actually use these options. So I will choose the British code. Okay, and then here you can, and by the way, here it is the automated load generation. Okay, and then here you have the generate loads, and then you have 3 loads, and then you can press on add. Okay, and then close. See here, you have actually, this generated load combination automatically here. So for changing them, because we know that actually is not Eurocode based, so that's why maybe I can just come back here, select the first option, and then go to edit.
Okay.
Okay, and then from here, see from here, simply I can change it. In Eurocode, I know that the live load is 1.35, dead load, sorry, 1.35, correct? And then the live load is 1.5, the factor is 1.5, and bin load, maybe also we can go for 1.2. So why here, actually, I have 3 cases. If I just, let's say, close this. See here, the first one is self-bait, the second one is dead load, and the third one is live load. So we know that self-bait is the dead load type. So that's why here I put 1.35. Dead load here, it is number 2, sorry. Once again, come to select this and then edit. Okay, so here also I have the load case 1, load case 2, load case 3. So for load case 1, which is self-bait, I know it is the dead load type, so I can say 1.35. The second one is dead load again, so I will put 1.35. And the third load case is live load. So here I will put 1.5. Okay, and then from here I can say modify. Okay, so modify, but also here I have the naming for my load combination. Maybe from here also I can change this one to 3.5. Okay, and also 3.5. And here 1.5. Again, modify. Okay, see right now here we have this. So the point is that if you don't want to generate the load combination manually, so you can use any existing code that you have here, and then you can come back here and edit it. Okay, so the next load combination, for example, here, so close this one, I can come to this option and again edit. So again, from here, I have the load case 1, 2, and 4, which means self-bait, dead load, and bin load. Okay, for the here, again, I can say 1.35, also 1.35, and the load case 4 is bin load. So from here, maybe I can just keep it as 1.4. So I need to review the load combination according to Eurocode. Okay, and from here again, so I can change this one to 1.35. Okay, 1.35, and wind load is 1.4, and then modify. Close. And the last one here, I can go again, select and go to edit. So here I have all the load combinations. So again, for the load case 1, which is self-bait, and it is the dead load type, I will put 1.35. So the next one, load case 2 is dead load, 1.35 again. Load case 3 is live load, 1.5. And load case 4 is bin load. So I can put it as 1.2. So just a little bit reduce the factor because here I have both dead load and live load. Okay, so that's why I'm going to have the factor of 20% for bin load. And from here also I can change the naming. Okay, so 1.35, 1.35. Live load, I can say 1.5, and wind load is 1.2, and then modify. Okay, so right now I have this load combinations. Again, save your model. So now we did it, and then we can go to analysis tab. So from here, the first thing that I need to do is just, come to this option and then press on this define command. So just press on this define command, and then from here, click add. Just add. And then, so here, this perform analysis will be added here. And then close.
Okay.
You did it, Mohammed?
Okay, clear, sir.
Okay.
So after we close the define comment, so
Yeah, okay. Close everything. After perform analysis, you can see here, close everything. And then come to this option. See here, run analysis.
analysis. Okay.
Okay, so just press this button. Save, yes.
Oh.
Okay, so right now I have one error. So I need to check the error. What is the error? Okay, so I can go to view output file. Okay, so then click on done. So let's see what error we have. Okay, so density not provided. Okay, see here, density not provided. So which means self-bait command is ignored to some members. Okay, so simply I can go back to select option, go to select. And here I have the missing property option. Okay, so from here, just click on the last one, missing property. Okay, so nothing. If I select the missing elasticity, nothing. So here I have the missing density, nothing. So it's kind of a strange thing. Okay, never mind. So I can go back to loading. I can go to self-bait. So from here, I can see self-bait actually assigned to every member. So once again, I will select the self-bait and then assign to view. Okay, and then assign. So also you have that error, Mohammed?
Error.
You don't have any error.
Error what?
One error.
Yes, one error.
Oh, okay. So just again, reassign the self-bait. So let me go back to analysis and then run the analysis. Let me see what happened this time.
So if there is one error, we need to redo again for the sign.
Yeah, I need to find the source of the error. Okay.
Okay.
So here the error actually was if again, see here I have one error, and then if I go to view output file, and then here if I press OK, done. So here I have the error. Okay, so here you can see STAAD.Pro error message. So if I double click on this, see here I can see density not provided, self-bait command ignored. Okay, so I have actually different options actually to see this. So first of all, as I showed you, so I could go to select option and then check the missing elasticity, density, Poisson ratio, alpha, or properties. Okay, so but it didn't work. So the next step that I did, I went to loading, and from here I selected the self-bait, and again I reassigned the self-bait to view, but still it hasn't worked. Okay, so the next one, if I go to material, so I want to check the material. Okay, from here also I want to select the concrete. From here, see, from here I want to select the concrete. Oh, sorry, my STAAD.Pro crashed. We said we can go to the material, and from here I want to select the concrete. Okay. And then from here I want to assign to view. Okay, because again, this concrete is actually has direction relationship with the density, yeah? So it is another possible way that we can do it. So I can assign to view, assign, yes. Okay, so right now I have this. And again, from here, let me go back to analysis once again, and then run the analysis. See, this time still we have the error or not. If we have error, so we need to do something. So right now is perfect.
Oh.
Okay, so right now is working well. So which means once you have, some kind of error like this, so you have different options to check. Okay, so right now we have this, and then if you go to post-processing mode,
Okay.
which means the second option, and then done. So here you can select, all these loads here, the selected load,
Okay.
and then click OK. And under here, you can see different options. See here, you have, all the results here. Let's say, for example, here you have the displacement, so you can see the displacement. If you want to, exaggerate, or let's say scale up or scale down the deformation, you can press Control and then play with your mouse scroll. Okay, just like this. Okay, press Control and then play with your mouse scroll. You got it?
Yes, sir.
You can do it, yeah?
Yes.
Okay, so now let me, for example, this time I don't want to see the displacement. I can click on this to deselect this option, see here, and then I want to see the moment. So that's why I can go to MZ, for example, from here. So I can see the moment, just like this. Okay, and maybe also I want to see the reactions. So here I have the reactions. Okay, so for this reason, just I will click on the reactions. And from here, you can see the reactions. Okay, so you have different reactions for different nodes. Okay, so it is the thing that we needed for design the foundation.
Oh, this thing.
Okay.
Okay, sir.
So now I can go to, let's say, again, please save your model. So from here, I can go to the foundation design. Okay. So I can go to, let's just deactivate the reaction. Okay, go back to press on the displacement. Okay, and then also deactivate this displacement. So I don't want to see anything. So right now I can go to the foundation. Okay, so click on the foundation. And right now we have this new window. So here I have the load cases and combinations. So I need to include all this load and combination in foundation design.
Okay.
Okay, and also here you have the option support for foundation design. You have three options. So you have the all support. So if you select all support, so which means all this reaction will be exported to STAAD Foundation Advanced to design the foundation. And here we have the selected support. For example, here I can go to select, and then I can select the node cursor. And for example, I can select, for example, this this node, press Control, this node, this node, this node, this node.
Okay.
And then from here, if I want to only design this foundation for these nodes, so I can go and select supports only. And then here also you can go to listed support. So if you know the, let's say, number of the nodes, so here you can, if you go back to analytical, go back to analytical modeling. see here right now and go to the support, go to support.
Okay.
See right now, here I have only one type of support. So here I have the S2 only. Okay, which means all these supports are fixed. But if I want to create, any other, for example, pin support, for example, okay, so I can add it, and then I have two type of support, correct? So I have the S2 and S3. S1 actually is no support, so which means I don't have anything, but S2 is fixed. And if I want to add the pin support, so I can add it, and automatically, so the symbol for the pin support will be S3. Okay, so then right now, if you go back to foundation design, so here you have the listed support. Okay, so here you can say that S2, S3, S4, how many type of support that you have, you can list it here. Here?
Okay.
Okay, so now for this example, we are going actually, to have the all supports. So all supports from here. Just give me a second. Okay, and then I will select, I'm not going actually now to select, the load cases, just I need the load combinations.
Okay.
Okay, I want to select the load combination. It is the extraction of the loads, okay, and also factor loads. So then I can say include. So just I include the load combinations. Okay, and here at the bottom, I have the STAAD Foundation Advanced. Okay, click on this option, STAAD Foundation Advanced. Okay, so then STAAD Foundation Advanced software will be popped up automatically. Any questions so far, Mohammed?
So far, alhamdulillah, okay.
Okay, so how is the procedure? How is the,
For now,
I mean, yeah,
it's
is clear? Is clear the steps?
yes, very clear.
Okay.
Oh.
Okay. So just a little bit more, just to have everything here. Okay, see here, I have all the supports, including the load combinations, effects. Okay, for example, here, so for STAAD Foundation Advanced, let me just briefly introduce you this software as well. So here we have the, the home tab. Under home tab, as you can see, you can save as, whatever actually you want. Simple. If you want to open any file or new file, you can come here. And then here you have the design or analysis. So this is actually, we work on it a lot. And then here you have some other, let's say, interoperability or integration between STAAD Foundation Advanced with STAAD.Pro, or with your spreadsheet or Excel file that you have. And here you have actually the load types. For example, here we have 3 load types. Remember, these types we created in STAAD.Pro, but right now we have it in STAAD Foundation Advanced. So right now, the thing that you can see here, it is under load combination number 5. If I change it to load combination number 6, see here you have this. If I change it to load combination number 7, so you have this.
Okay.
Okay, and here you have some general settings. Okay, for example, here you can set the units. If I click on this, so right now I'm in the SI unit, so which is the thing that I want. But if you want to change the, to English unit or imperial unit, so you can change it from here. So English unit. Okay, so here you have the English unit or imperial unit. But let's go back to SI unit. And here you have the, let's say, view option. So from here, if you want to change, the load color, or I don't know, the beam color, or if you have any plate color, so you can come here and then do it. And then here you have the global setting. So here under global setting, again, I'm not going actually, to go through, these options too much, but for your general information, so here you have the general setting for the reinforcement increment. Okay, so which means, for example, if you have the, or let's say under the design, if the foundation required reinforcement is, for example, 1,000 millimeter square. Okay, so
Okay.
then, so we can come here and then say that, the for incremental growing the area of reinforcement. So we can actually come here and say that, first of all, we have the spacing. For example, if the spacing we specified as 200 mm or 300 mm. So if this 300 mm doesn't meet the requirement of the code or of the design, so we will tell the software, okay, so the next try, go to put 300, for example, 5 millimeter. Okay, so again, if it is not meet the requirement of the code or of the design, so in the second or third iteration, so it will put 310 millimeter. Okay, it is like that. And it is actually, good for, let's say, have the optimal design. And then here you have the information about the foundation. So for example, here you have the always, calculated top reinforcement based on the concrete and soil weight, or you can go for calculate top reinforcement only when foundation is subjected to uplift force. So you can review it by yourself, but right now I'm not going actually, to discuss about it because of the short time that we have. So also tomorrow I need to cover some other options in foundation design under STAAD Foundation Advanced. And here we have the pedestal analysis and design setting. So it is just regarding the pedestal. So for pedestal also we have some other options. So later on we will talk about it. And here you have the scale setup. Just for example, here you have this, scale for forces. So right now, for example, here I have the point force. If I change them, see here, you can see the scaling. Okay, or for example, moment. See here, if you want to scale them to see it better, so you can come to here. And here also you have the view options. Okay, so you have the isometric view. You have the front view, back view, side view from left, from right, top view, and also bottom view. So again, under view, also here you have different options. Same thing here you have here, and then you have the zoom in, zoom out, zoom all. It's not that important. For example, here also, if you want to show the grid system, so from here you can just activate the grid system. But right now, since we exported the file from STAAD.Pro, so we haven't have any grid system, but maybe in the next example, so I will show you how you can even create the grid system as well. And then from here you can show or hide the grid system. And if you want to change the background of the interface, so here you can come to change background. Right now is black. For example, I can change it to white, just like this. Okay, or I can change it to any let's say background that I want. Okay, so but by default is black.
Okay.
And then here we have the tools. So again, is not that important because within the design procedure, I will show you how you can do it. So it is all let's say repetitive parameters. Okay, and then under help, so this is nothing. Under help, you can come here, and then the most important thing here, you have the verification manual. Okay, it is very useful if you click on this. See here, let's say, for example, you are using the Eurocode. So here you have the Eurocode. You can just expand this option. And here you have, design of different type of foundation. For example, combined foundation, isolated foundation, pile cap foundation, according to EC2 or Eurocode 2. Okay, and if you click on each of them, for example, here you have a very, very detailed verification. So for example, here you can see the vertical load, strength of the concrete, grade of steel, column dimension, pedestal height. So you have all this, and then here you have the geometry, and then here you have the calculation. It helps you a lot. Okay, and here you have the critical load case and the governing factor of safety for overturning. So you have the calculation, and then you have all this, and then here you can see the, let's say, the hand calculation result. And then here you have the flexural design about the z-axis, about the x-axis, and then area of steel required. Okay, and then check for one-way shear, for two-way shear, punching shear, which means, and here you have the, the overall result that you have for this, let's say, combined foundation using hand calculation. And after all, so you can come here and see here you have the comparison between the hand calculation result and also STAAD foundation result. Okay, so here you have this reference result, which means hand calculation result, and here you have the STAAD foundation result. So, and as you can see here, you can see the differences.
Okay.
Okay, so this is very useful document that you can find under help verification manual. Okay, so it's clear. And then from here, also from this tab, you have different parameters. Okay, so the first one is start page. Whenever we want to create a new project, so simply we can come here and then we can create the new file. Or if you want to open any file, you can open the file. Here also you have the examples. Okay, so you can go to the examples. And then the next one is the geometry. If you created any foundation, so to see the geometry, you can just click on this option, and then here you can see it. And here you have the detail and schedule drawing. Right now, we haven't analyzed yet. That's why here we cannot see. And then also here you have the GA or general arrangement drawing. So still we haven't analyzed. And then here you have the calculation sheet. So still we haven't analyzed and designed to see all the, let's say, calculation. Okay, and the last one is graph. So let's go back to our geometry. And from here, so we have actually, two parts, two main parts, okay? So I can say that this is the first part,
okay,
okay? And this is another part. So I can say that part 1 and also part 2. So why I'm saying this? Because right now, just we exported, the foundation, including, their loads to STAAD Foundation Advanced. And here, the part 1 is whenever we want to create our own, let's say, foundation geometry from scratch. Okay, so we can come here and then go through the procedure. For example, foundation plan, loads and factors, and soil properties or parameters. Okay, and then so we can do it. And after that, we can come to the create the job. But right now, since we have, for example, you have the foundation plan, yeah? So here it is our foundation plan. And then we have the load and factors. See here, we have the load and factors. Okay, and for soil properties, so either even under job setup, so we can adjust it. But for now, if I go back to here only, until, here, soil properties, if I click on here, even from here, actually, I have all these options, okay? So means that we don't need to care about this once we are exporting the foundations from STAAD.Pro to STAAD Foundation Advanced. So simply you can, ignore the first part, which means here, and come to create job. Okay, so it is for exporting whenever you're actually exporting your foundation geometry from STAAD.Pro to here. But once you want to create your foundation from scratch, from A to 0. So you need to also consider this part as well. Okay, which means maybe tomorrow we can go through this. Okay. So for now, I can go to job setup. I can just expand this job setup. And here I have 3 options: create a new job, edit current job, and delete job. So right now, the first option is create job. So I can click on create job. Okay, and from here, first of all, I need to make a decision. So what kind of foundation I want to design: isolated foundation, combined foundation, mat foundation, pile cap. So what kind of foundation I want to have? Okay, that's why here I can say that, for example, for the first example, I can say that isolated foundation. Okay, so I can just name as isolated foundation. And if you come to the job type, okay, so here you have the isolated, and here you have the drop-down menu. So here you can see isolated, pile cap, mat, combined, octagonal, strap, and vibration machine foundation. And also you have the combined with rib. So for the first example, as we said, I'm going to have the isolated foundation design. So that's why I will select the isolated. And for the codes and units, so I will come to design code. I will select the Euro code here. Okay, the unit I will change to SI. And here, the support assignment. So if you click on this, here again, you have same option that we had in STAAD.Pro interface. Remember, you have the assign to all support, assign to selected support, assign to listed support. So for this example, actually, I'm going to show you maybe 2 cases: assign to all support and assign to selected support. First, I will go to assign to selected support. Okay. So for this reason, so I can just simply, just click on this support, for example, this, and this. You can press Control and then, select the support. Okay, I will select this 3-1 and this, let's say, 3 support. So right now I selected 6 supports.
Okay.
Okay, and then here I have the loads. I want to include all this load combination to design this 6 supports. And then from here, I can select all load cases or combinations. Okay, and then create job. Okay, job isolated foundation has been successfully created. Okay. So now here also you can see isolated footing job is created, and you can see here under job setup. Remember previously we said that we have the create a new job, current job, delete job, but right now we have also this because we created an isolated footing job. So I can expand it. So here I have some options that I need to take care of them. So the first one is concrete and reinforcement. Okay, it is important. So if you select on this, so here at the right-hand side, you have this information. So the first one, also you can, from here, you can just, make it bigger. Okay, so the first one is the unit weight of the concrete. So let's say here, we can say that 25. Minimum bar size, bar spacing. So I can say, I don't know, maybe 100 mm. Maximum bar spacing, I can go for 450, I can accept it. Okay, and then strength of the concrete. So I can say that 30.
Yes.
Okay. Yield, if in each parameter, if you have any question, please ask your question.
Okay.
Okay, and then here we have the yield strength of the steel because we need to add the reinforcement. So here, again, I can accept this 415 megapascal. And then I have the minimum bar size for footing bottom. see here you have this option. So here you have the bar size for footing bottom, and you have the for footing top. Okay, so here for footing bottom, I can say that I want to have the number maybe 12. Okay, and then here I have this is the yeah, so minimum bar size for the footing bottom, I can say 10, and maximum I can say go to 25. Yeah, it's okay. And also for top, the minimum I want to consider as, let's say again 8, and maximum I can go for 16, for example.
Okay.
Okay, so here I have the minimum pedestal bar size. As you can see here, I don't have any pedestal because I exported from STAAD.Pro and I don't have any pedestal. So, and the rest is all, related to pedestal is deactivated. I cannot change them. And here I have this set as default. So in future, if I want to use this option, so I can just save it as default. So later on, if I open, any STAAD Foundation Advanced file, so I will find actually the same parameter that I set it right now. So here I have the set as default yes, and then I can go to next step, cover and soil. Okay, so here under cover and soil, again, I have the pedestal clear cover. So I don't have any pedestal, so I'm not caring about it. Bottom clear cover. Okay, so I can say 40.
Okay.
Okay, and then base value of soil bearing capacity. So here you can get actually, this information from the geotech engineer, but from here, maybe I can say 150. Okay, multiply on soil bearing capacity for ultimate load. So here maybe also I can change this one to 1.5. It is for safety factor. Okay, and then depth of soil above the footing. So since right now we exported the foundations from STAAD.Pro to here, so I don't know, maybe again, so in the real projects, for example, here, if you have your, let's say, foundation here, okay, so if you have any, let's say, soil profile above this foundation, so you can actually get this information from the geotech engineer, and then you can put it here. But for now, just I'm assuming something. Even for example, here you can press 0. So for example, you don't have any soil above the footing. Okay, and type of depth. So here you have the fixed top or fixed bottom. Okay, so what does it mean? It means that, let's say I have this foundation, and then see here I have the for example, the depth of the foundation is 500 mm, for example. Okay, so the type of depth here I have two options, fixed top or fixed bottom. So it means that, for example, if I select fixed top, so which means if the software couldn't come up with the result with this 500 mm, so then the software add another thickness to this foundation. So it will become, for example, 550, for example. Okay, so once I selected fixed top, so which means here is fixed. And then so the increment of the foundation size will be increasing in this direction. If I put bottom, so here will be fixed. If I change this one to fixed bottom, so this time the software will add the required thickness to top, and it will goes in this direction. Okay, but usually it's better to put as top, because here we have, let's say, our column, correct? And then from here, we don't want to, increase the depth of the foundation in this direction. So here we have the soil in this direction, and that's why, so it's better to put it, or let's say adjust the fix button. And then, so here I have the surcharge pressure. So if you have any surcharge, which means, any soil or any other, let's say, material above the soil, above the foundation, so you can calculate it and then put it here. So we have the depth of water table. If you have any, let's say, water at the bottom of the foundation, let's say, for example, here the foundation, and then here is the soil, and maybe here you have the, the water level. So you can just, again, all this information you will get from the geotech engineer. So then you can put it here. Okay, so now this one, maybe we can accept this 2 meter is okay. And the rest, again, you can get from the geotech engineer. But right now, since I don't have any information, but I will just leave it as 0. So I have the, let's say, pi value of soil. And I have the minimum percentage of contact area for service load, and minimum percentage of contact area for ultimate load. Okay, and then I have this one as default. You can accept it, and then go to the next option, fix footing geometry. So I can come to here, and then here I have the first option is very important. So I have 2 options: calculate dimension or set dimension. So if you press calculate dimension, which means you are allowing the software to come up with a good solution for you. Okay, but if you press on set dimension, which means you want to design the foundation. So you want to force the software to design, for example, a foundation with, let's say, for example, 1 meter by 2 meter. So you want to force the software to design such foundation, which is pass the design or not. But if you select the calculate dimension, so by let's say the first try, maybe you can say that minimum length of the foundation right now here, as you can see, so you have 2 meter, and minimum width also you have 2 meter, and minimum thickness, which means depth, is 700 millimeter. Okay, so which means you have something like that. Let's say if you have, let's say, something like that, here it is the 2 meter, 2 meter, and then here you have the, let's say, 0.7 meter. And if you press set dimension, so the software doesn't go for, any other dimension. And if the foundation is failed, just the software report actually the failure. But if you select the calculate dimension, so if this dimension is not enough to carry out the load, so the software just, itself try to add the dimension. Okay, just like this. Maybe from this side, maybe here, until, passing the design. Okay?
Okay, sir.
Clear, Mohammed?
Alhamdulillah, clear.
Yeah, okay. So now I will go to calculate the dimension. Okay, so the minimum length, I will put, let's say, I want to start with 1 meter. Okay, so that's why here I said 1000. And a minimum width, also I want to start with 1 meter. Minimum thickness or depth, I want to start with 400 millimeter. Maximum length, I don't want to have the, more than 200 or let's say 2.5 meter. That's why here I put 2,500. Minimum width, also I put 2,500. And maximum thickness, so I don't want to have more than, let's say, 1 meter depth. And dimension increment along the x-axis.
Okay.
Again, see here, if I have this foundation. Okay, so here I have the x-axis, and also here, let's say I have the z-axis. Sorry. Yeah, it's correct. Okay, so here I have the x-axis, and here you can see this. So here is the, or let me just go back to just zoom on one of these foundations. Let's say here.
Okay.
Or maybe just give me a second. Okay, see here, I have the z-axis, and from here I have the x-axis. So let's say if this foundation is not enough, the dimension is not enough to carry out the load. So here I have the dimension increment along the x-axis and also along the z-axis. So which means software, just help me to come up with solution, okay, in this direction.
Oh.
So it is in the x direction, okay, and in the y direction, but the increment is 100. For example, imagine, so we said that, our first try is 1 meter by 1 meter, okay, so it is the 1 meter by 1 meter, correct? So if it couldn't pass the design, so then the software in x direction, put another, let's say 0.5, 0.1 meter, which is 100 mm. Again, try to solve the equation and come up with, a good design.
Okay.
If again is not okay, so again, the software add another 0.1, which means 100 mm in this direction. Same here, so in the z direction. So if it is not, so add, 0.1, 0.1. Okay, so you can adjust this to have this option. Okay, so now I can accept this. So which means only, 10 centimeter, once is not enough. And then thickness increment. So here also I have the thickness increment. So it is the thickness. And remember, in the previous step, we said that fixed top, remember? So that's why here, so right now I have the thickness increment as 50 mm. So which means if the thickness wasn't satisfy the design, so the software automatically add another 50 mm here.
Oh.
Okay, again, if it is not satisfied, again, software, add another 50, just like this. And we'll go up to past the design. So that's why here it is the meaning of calculate dimension. Okay.
Okay, sir.
And then here we have the offset x direction and we have the offset z direction. So you can see this, let's say, figure. And from here, you can see that actually, if you want to, let's say you have some eccentricity actually, because here right now it is the, let's say at the center of the foundation. If you add any, let's say, a value here, so which means you are going actually, to shift the column, in x direction to have some eccentricity. And if you want to add some value in the z direction, so which means you are going to, shift the, again, column to have some eccentricity.
Okay.
So depends upon the condition that we have in the project. So you may need to, put some value here. But right now, so I don't want to put anything here. So from here again, I can say click yes as a default. So right now we are on the footing geometry. So footing geometry done. So then I can go to sliding and overturning. Okay, so here I have the coefficient of friction, 0.5. I can accept it. Factor of safety against sliding, so I can accept it. Factor of safety against overturning, I can accept it, and then default, yes. And that's it. Okay, so after that, so I can just go back once again. If I go to, yeah, that's it. So I can go to just press on event either from here, design tab, or under home, here I have design or analysis. Okay, so here I have analysis and design. So doesn't matter. So right now from here, I can just press on design. Okay, design. Do you want to analyze and design? Yes. Save, I can save it. So once you save this one, so if you go back to your, the folder that you created, you know, the STAAD profile. So here you can see foundation design. You can see, you know, all this STAAD foundation files will be generated in the same folder.
Oh.
Okay, so now here we have actually something 12. It is actually, you know, just you know, the time that we've done the analysis. Number of warnings 0, number of errors 1. So
Okay.
what is the errors? Okay, so if I go to here, I cannot see anything here. Let me go back to here. Just give me a second. Okay, so we said that we need to find the error. So here I can see that footing maximum thickness, exit footing embedment. Okay, so if I go back to footing geometry, okay, so the maximum thickness, so here I can say that go to, for example, 700. Okay, so redesign. Okay, still I have this error. So I need to increment thickness, maximum thickness. Okay, so from here we need to find the errors. So we said that from here we have footing maximum thickness, exit footing, embedded depth. So if I look at the footing, so from here, again, I can say that maximum thickness, I can go for 700, I can accept it. So previously what, 1,000, 1 meter. But the source of this issue, it could be from cover and soil. So if I go back here, so here I can see that, you know, the type of depth, fixed bottom. So remember we said that if we have the foundation, so right now, I don't know for which reason I fix this one, and then so the foundation, or let's say the STAAD Foundation Advanced is going to, you know, just increase the size in this direction. So it is actually the reason. So what can I do? I can just change the fix bottom to fix top. So which means here I have the fix. Then in this direction, I don't have any limitation. So it can go to whatever it wants.
Okay.
Okay, so then I will change this one to fix top. And once again, I can design it. Save, save. Okay, now it's going well. And right now, as you can see here, we don't have any error, we don't have any warning.
Okay.
So now I can go to the detail. So because here right now, remember we said that we are actually, we create the job for this foundations, yeah, for this tree and for this tree, correct?
Okay.
So if I go to here, see this option, show current job supports. If I click on this, so it shows me only, the foundation that I'm working with.
Okay.
Okay, so I can see only those supports, right? And then I can go to detail and schedule drawings. So from here, as you can see, so it comes up with a solution with the same dimension for all these 6 footings. Okay, once you have, one, let's say one dimension, so which means all of these 6 supports have same footing dimensions. But from here, also you can see if the, other footings, for example, I can go to footing number 4. So from here, I can see, for example, here, the depth of the foundation is 40. But if I look at the 1, see here, also is 40. And then here, we have the cover. If you remember, we set it for 40 millimeter. If I go back to here, see, we put as 40 millimeter. Okay, that's why here we have the 40 millimeters, 40 millimeters. Okay, so let me go back to here. Okay, right now we are under footing number 1, and the dimension is 160 by 160. Okay, which means 1.6 meter, 1.6 meter. Look at the number 4. 1.9, 1.9. It gives me different dimension because I didn't force the software to design what dimension that I want. Okay, so according to the applying load, so the software just, gives us, the most appropriate dimension and depth. So after that, I can go to GA drawing because from here I understood that, the foundations have different dimensions. So I can go to GA drawing to see them. See here, for example, this one is foundation number 14. It is number 15, and it is number 16. So from here, I have foundation number 1. I have number 2. Sorry, let me go back here. 1, 4, 6, 25, 20, 30. Okay, so it is not actually. So here I have number 4. Sorry, I have the foundation number 4. I have foundation number 6. And also I have the foundation number 1. And here also I have the foundation number 25, 28, and 30. And this one is the footing actually, footing number. Okay, so as you can see here, these 2 footing numbers, this is 1.6, but this one is 1.9. Okay, same here. If I go back to here, so same. So this one, it is number 25. See, if we go back to see this, it is 1.6. And from here, simply you can see the geometry is smaller than this one. And not only that, from here also you have, the general information. So you have the footing number 1, footing number 2, footing number 3, footing number 4, footing number 5, and footing number 6. And here it is the dimensions.
Oh,
Okay, and from here you have the column numbers. So you have the column number 1, 4, 6, 25, 28, and 30. So after that, you can go to the calculation sheet. So let me just make it smaller. So from here, we can see, you know, the just calculation, for example, for foundation number 1. And from here, you can see, you know, for example, load combination. If you click on load combination, so here you have the load combination that you applied, and we had it from STAAD.Pro. Okay, so here you have the applied loads on top of the column. So here again, you have all this information. So you have the fx for column number, let's say, sorry, for load case number 5. And here it is minus 6 point something, and fy, fz, mx, and mz. Okay, so this was applied as a service load, and this was applied as the, let's say, ultimate loads. Okay, the next one is the gross pressure at 4 columns. So here you have this column schematic, and here you have 4 load cases because we had the, self-weight, correct? We have the self-weight, and also we have the dead load, live load, and also the wind load that we created from STAAD.Pro. And here you have, based on this, so the software calculate the, the pressure at the top left, at the top right, so which means here, 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 which means top left, here, top right, okay, pressure at bottom right, so which means here, and here, and then pressure at, and also the uplift. Let's say here, if it is the foundation, if we have any, uplift pressure. Okay, since here we don't have any uplift, so as you can see here, it is all 0. And yeah, and then we had the, let's say, the bearing capacity, gross bearing capacity. Okay, so here the, let's say, the unit is kilonewton per centimeter squared. And if you remember, we assigned this as 150 kilonewton per meter squared. Correct? So we have this, and then the next one, you have the stability check. So here you have the stability check. Okay, so here you have this, let's say, information. Resistance force along the X is 2.25 kilonewton. And here you have the factor of safety against sliding, and also factor of safety against overturning along different axes. Okay, the next one is punching shear check. So again, it gives you, all this information. Okay, punching shear check at two, let's say, different side of the columns. Punching shear check at column face, which means here. And then here, the next one, you have the reinforcement calculation. Okay, so it is for, let's say, total reinforcement that we have to calculate. And so here we have the one-way shear. Okay, and then we have the flexure about the x-axis, and also flexure about the y-axis. So it means the foundation. And finally, you have actually, this, let's say, result with the information. as you can see here for foundation number 1. So you need to provide, for example, at the bottom, you need to provide, the 14 number of reinforcement with 10 millimeter diameter.
Okay.
Okay, and at the top, so you don't need to put anything. So, and also this can be clear from, again, if you go back to here, you see here at the top, you don't have any reinforcement. Okay, so it is for, let's say, just workflow from STAAD.Pro to STAAD Foundation Advanced.
Okay.
To have the, or let's say to design the isolated footing. So if I go back to, once again, job, so here I have the job. Remember for this job, if I go back to edit current job, if I go back to edit current job, see here I have the listed of the support. So which means I selected only 6 supports.
Okay.
So, but this time I want to go back to create another job.
Okay.
Okay, see again, so I'm showing you that, you can create, several jobs in one STAAD Foundation Advanced. Okay, so from here, I will go back to create another job. Again, so from here, I say that, isolated foundation. This time I will say for all. Okay, see here, I have for all. And then here, the isolated is selected. So the code, I can change it to Eurocode. The unit is SI and assign to all support. If I go back to geometry, so from here, doesn't matter it's selected or not.
Okay.
But from here, I am going to assign to all support. And then here, I will select the loads and then create job. Okay, so this job also is created. Okay, so this time I will come to once again here. As you can see here, I have all these default values that I assigned before.
Okay.
Okay, and then I can go to cover and soil. So I have this. Okay, and then putting geometry. So I have this. Sliding and overturning. So I have this. And then once again, I can design.
Okay. Okay, now I understand.
Okay, so right now we have actually,
Okay.
if I go back to here, as you can see, so all the supports are listed here, correct? And then if I, from here, right now we have the detailed drawing. Okay, so also here I can go to the schedule drawing. So under schedule drawing, so here you have the, let's say, overall schematic view of the foundation. So here I have the, the steel area at the top, steel area at the bottom. So here I have the cover, here I have the depth, here I have the, let's say, height of the pedestal, if I have any pedestal, okay? And here I have the, let's say, column or pedestal dimension.
Okay.
And here it is the top view for dimension of the foundation. So here it is the L and B. And from here, you will get, all the information, foundation mark. So here we have the F1, F2, F3, F4. So we have to have, let's say, 15 number of foundation. And then, so the next one is the column number. So column number 1, 4, so up to all. And then here we have the column dimensions. see here, remember in the STAAD.Pro, we put the columns as 45 by 45. So that's why here you can see all set as 45 by 45 centimeters. Okay, and then here we have the foundation. So again, here you can see, for example, for foundation number 1, so you have this. So here you have the length of the foundation is 1, maybe let me just, yeah, it is 4. Okay, it is centimeter. So which means for foundation number 1 is 4 meter by 4 meter almost. Okay, and by 1 meter depth.
Okay.
So as you can see here, this 4 meter is too much, yeah? So that's why you can go back to change the method from the calculate dimension to define the dimension. So here we have the reinforcement information. Okay, so at the bottom. So at the top, as you can see here, we don't have any reinforcement at the top. So all are empty. And the last one is the pedestal reinforcement. Again, if we have any pedestal. But right now, since we don't have any pedestal, so nothing is found. Okay, go back to detailed drawing. So it was actually for scheduled drawing. And then if you come to the GA drawing, so from here, you can see the, let's say again, the dimension of the footings. And then you can come to the calculation sheet again, so you have the same thing. Okay. And from here, if you want to print the, print the report, so from here you can just print the report. From here, you can save it as PDF. Okay, so if I want to print it, so just print. Okay, so here I have this, and then let's say export job.
Oh, 11 pages.
Yeah, actually 11 pages is fine, because some other software are very detailed and they produce maybe, 100 pages.
Oh.
Yeah, but this is STAAD.Pro, STAAD Foundation Advanced is, the report is very summarized, very detailed, and very easy to understand.
Yeah.
Okay, so I can save this one, for example, in my folder that I created. Foundation design. Okay, so I can put it in the foundation design, the one foundation, and then here save, and then close. So if I go back here, this folder, see here I have this report. Okay, it's very detailed and at the same time is very summarized. I really like it. Okay.
Okay.
So now it was actually, for this. So if you have any question, so we can discuss. Otherwise, for tomorrow, so we will.
Okay.
Any question that right now you have?
So far, I understand, clear.
Okay, so how was the training?
I think it is more easier, easy, a little bit easier from the AutoCAD.
What do you mean easier from AutoCAD?
This one is you just put the detail and everything, then it will get the result. Like
Yeah. In AutoCAD, actually, yeah. Once we are thinking about the AutoCAD, because in AutoCAD we cannot design anything, so we will get the dimensions. For example, from a structural engineer once he designed the foundation, and then for example, we as a drafter, so we need to just create the geometry in the AutoCAD, include all dimensions
yeah.
and reinforcement information. So it is the way. But from here in STAAD Foundation Advanced, so see this option,
Yes, self drawing.
save drawing as.
Okay.
Okay, so you can click on this, and then from here I can save it as, you can see here, DWG format. Okay, or you can save it as DXF format. So it's very simple. Okay, so for now I'm going to save it as DWG. And then from here, let me just, save it again in my desktop in the same folder. Okay, so I will go to here, and then here I have the foundation design, and then foundation design 1, and then here I can save it. Save. Okay, now if I go back to the folder, see here I have this drawing. So if I open this drawing, okay, see here you have the drawing for foundation number 1. Okay, so you don't need to, let's say, even, recreate it in AutoCAD. So right now you have it. So it's cool?
Cool.
Yeah, so if I go back to here, if I go to the options, so also from here, you can actually, change the colors if you want. Okay, so in the CAD, in the, let's say, CAD drawings, if you want to change the colors, you can come here and then change the colors. Okay, it's clear?
Yeah.
Okay, so yeah, so that's it. And then any other question, Mohammed?
For tomorrow, what time? Yeah?
For tomorrow, let me just give me a second, please.
Because